Hi, and welcome back to my video series on refactoring. In this series, I spent some time cleaning up and modernizing a very old C++ codebase to bring it up to modern standards and improve the code. And so today, we want to run clang-tidy and fix all the problems that it highlights. So we already looked at a little bit at the warnings from clang-tidy last time, but we didn't actually get to applying any of the automated fixes that it can do. So that's what we are going to do today. But first, I want to take care of some loose ends. And so last time, we did this change here, remove unused code, where we removed a bunch of code that's not actually being used. And a large part of this code was in this direct input manager, where we removed mouse and joystick input support, which is not actually used anywhere in this project. And so the thing is, I removed all this code, but I left some of these related function arguments in place. Like in this init function, we have this argument int def, or for device, which is used to indicate what kind of input device is being used. And so I left this in place in the first step in order to not have to change the client code of this class. But now that we've cleaned up all this unused code, we should go one step further and also clean up the client code and get rid of this now unused parameter, because right now it's not used anymore. Okay, so let's do just that. So we go to the direct input manager, and we have this in two places. So we have this argument here in this init function, which we can get rid of, and then also in this flush function. But let's first do this one, and then when that compiles, we can deal with the other one. Okay, so remove it from here. Go to the direct input manager and say find usages of this init function. And then it directly points us to this place. So that's also nice and easy. So let's do that and then remove the argument from here. And so now code should still compile. And it does. Let's see if it still runs. Yep, looks good. Okay, cool. So that's this one. And then we have this flush function where we have the same thing. So let's get rid of this argument. And then let's find the usages. Here, flush, find usages. And this one is used in a few more places. And well, this is commented out code, so we can also just remove that. And seems like it's all of them. So all of them are in the main CPP file. So I can just find them by name, and that's that. So that should also still compile, and it looks good. And so now that we've removed this argument, now we can also get rid of this use keyboard define. So let's see if that's still being used anywhere. Find usages, nothing found. That's good. So let's get rid of it and recompile. And it still runs. Cool. Yeah, so this is just a little thing going further with this cleanup that we did. So we cleaned up the internals of this class to remove all this code that's not being used and made these arguments to these functions meaningless. And so then the next step is to remove them from the call sites and clean up some more code that way, which we did. And so it's not a huge change, but it cleans up some more a noise from the code. Okay, so let's commit this. And separately commit remove commented out code. Okay, cool. Yeah, so that's this one loose end I wanted to take care of. And now we can start looking at the clang-tidy warnings. And so we started looking a little bit at this last time. And the first one here is this constructor doesn't initialize these fields short data, which is not true because we have this zero memory here, which is basically a mem set to 0. But I mean, this is not the idiomatic C++ way of how you would do this. Better way would be to, because this short data member is of type sprite description. And so an easier way to deal with it would be to make this struct have proper default initializers. But that's getting ahead of ourselves. So because these are clang-tidy warnings, we can also let clang-tidy fix them for us. But that's not what I want to do now. What I want to do is to first address these issues that occur many times. So we have this one, which we talked a little bit about last time, where many of these functions that take no arguments have a void, which they don't need. And then also we are now using C++20, so we can use null pointer instead of this null constant. And these are all over the place. And so we really want to kind of do a batch processing and fix them all in one go across the whole code base. Yeah, like use null pointer, use range-based for loop. And so ideally, what I would want would be something like to be able to go here and then do something like click and fix this for the entire project. Unfortunately, I wasn't able to find a way to do that. Maybe there is one and I just didn't find it. Maybe it's not possible. So what we can do is we can click here and then it does automatically fix this one instance, but it doesn't fix all the other ones. So what I'm going to do instead is to manually invoke clang-tidy on the command line to fix these issues one by one. And then we can make a commit for each type of issue. So for that, we need to know what the name of this check is, the name that clang-tidy internally uses. So the way clang-tidy works is you specify a list of checks. And if you invoke it on the command line, a typical way that you can do it is to say -*, which basically means disable all the checks, and then list the checks that you do want to run. And so in this case, we only want to run a check called modernize use null pointer. Run clang-tidypy is a helper Python script that comes with the LLVM binaries if you download a build of LLVM. And then the arguments we need, in order for it to work, we need a we need this file compile commands JSON, which is generated by the build process if we say that it should be, which we can do by going in clion. So if you invoke cmake on the command line, then you would specify that when invoking cmake, -d cmake export compile commands equals on. I'm using the clion cmake integration, so I can specify it here. I go to the cmake section, click on this little gear icon, and then I can pass in additional cmake options. And so that's where I put this. And so you put this in, and then when you compile, cmake outputs this compile commands JSON file. And that file essentially is a list of all the command lines that are going to be, that the compiler is going to be invoked with when you build the project. And so that way clang-tidy can figure out the compiler flags to use when analyzing the code. Okay, and so we need to be in this directory where this compile commands JSON file is. And then we can use this helper script. And the helper script is then going to run clang-tidy on all the files in the project using this configuration where we only perform this one check, modernize use null pointer. And we also say -fix because we want clang-tidy to automatically fix it. So let's run it. It takes some time. And then if we look at the changes, then we can see that it has replaced null with null pointer everywhere. And yeah, so that's pretty cool. Still builds and still runs. Cool. All right. So let's commit that. Clang-tidy null to null pointer. And then the other big one was this redundant void argument list in function definition. And so now if we want to manually run the fix for that from the command line, we need to know the name of this check. And so actually let's have a look at the website, the documentation for clang-tidy. Now this is for version 15 and I'm using version 11, but I don't think it matters in this case. So this is a list of all the checks that clang-tidy can do. And then if you click on an individual check, you get more information about what exactly it does and if there are maybe some options and so on. And so we want to, I can already see it, modernize redundant void arg. That sounds pretty much like what we want. Yep. So let's run this one. Okay. And it runs. And let's see what it did. Seems like it did what we wanted to do. We might want to, actually, now that I think about it, also rerun clang format after running clang-tidy, because some of the changes that it makes, like converting null to null pointer, might change the code in a way that the formatting would change. And let's see. And so these changes should actually be part of this commit. Okay, so we do need to run clang format once after each run of clang-tidy. So now we can do the redundant void arg. And let's also run clang format again. And now let's see. So yeah, this looks good. Remove the void from all of these function declarations, much less noisy. And so yeah, I'm just kind of skimming the changes, not looking at each individual one, because I generally trust that it's going to do the right thing. But we are going to compile and run just to make sure. Cool. Looks pretty good. And we get a crash after quitting, which is also interesting. But that's something we can fix later. Cool. So now apply clang-tidy, remove redundant void args. Okay. Then let's go back to the problems. So narrowing conversion from int to float. use auto. Right, so these conversion ones I'm gonna look at in a sec. But yeah, we can see how many of these null pointer and void argument lists already disappeared now. So that's nice. So before we go into these narrowing conversion ones, let's maybe use this one. Let's see if we can figure out, because this one I can imagine also occurs in multiple places in the code base. So let's see, auto, modernize, replace auto pointer, that's something else. Modernize, use auto. This sounds like it could be this one, so let's see. Modernize, use auto. Yeah, I think this is one that was highlighted here. Yeah, on sprite fire, that's exactly the one. And so we're using auto to avoid having to type the name of the type twice, which makes sense, but also in general using auto, well, it's sometimes a bit controversial. People have different opinions about it. I personally like using auto a lot. I think it makes for more readable code. In this case, it definitely helps avoiding this duplication and makes the code a bit easier to refactor. But anyway, we are not going to keep using manual memory management, so this is going to change later on also anyway. But yeah, that's good to change this. Okay, so that seems that's all the ones that it did. Also run clang format, just to be sure, but it didn't change anything in this case. Okay, so this is this one. Then we have more narrowing conversion stuff. Parameter is const qualified in a function declaration. Const qualification of parameters only has an effect in function definitions. That is true. So in C++, in the function declaration, if you have a type that's passed by value, so not by pointer or by reference, then a const in the declaration is essentially meaningless. It's ignored. So you can put it or you cannot put it. It does not make a difference. It does make a difference in the function definition, because if you, so let's actually go to the definition of that function. Right, so inside of that function, we cannot assign to R because it's const, but we could remove this const here and then do something like this, and it would compile, even though we have the const in the declaration, because the const in the declaration does not matter. Only the const here in the definition matters for non-reference, non-pointer types. For reference or pointer types, it needs to match between the definition and the declaration. Yeah, but for value types, it makes no difference. And the reason is that for the call side, it essentially doesn't make a difference because it's by value, so we are making a copy. And therefore, it doesn't matter for the caller of this function, whether the function internally treats this value as const or not. Because the caller can be sure that because it's by value, a copy is going to be made anyway, and the caller, the function is never going to modify the caller's value, if that makes sense. So yeah, these consts should be removed. I don't know if this one is one of these that happen across all of the code base, so maybe for now we're just gonna apply these fixes within the IDE. And then we can reformat also. Cool. So now we have these narrowing conversion ones left, and the doesn't initialize one, but get to that one later maybe. Range-based for, that sounds like something that we can also fix across the entire code base. Let's see what else we have. Deprecated C++ header. Range-based for. Yeah, so let's run range-based for. Modernize loop convert. Yes. Check converts old style for loops to use the new range-based loops. Okay, so that's what we want. And it seems there are actually some options. Risky, reasonable, safe, which kind of influence what kinds of transformations the automatic fixing is going to do. But I think I'm just going to rely on the default here. And let's see. Modernize loop convert. Cool. What did it do? So here. Right. Actually, I want to. So I didn't commit this change yet. So I do actually want to revert this one because this was just me illustrating something. And then here this is removing these const from the function definition. I'm not going to commit that one yet because there might be more of this type. But so here we can see, that's a bit weird. It does for auto reference I, but surfaces to release is a, okay. Surface to release is a array of LP direct draw surface 7, which is a pointer to a surface. So does it make sense? Yeah, we need to take these by reference because we want to modify what's the elements of this array. But the variable name I is kind of not a good name anymore if we use a range-based for loops. So let's actually call this surface. All right, and then we have the same thing here. It's interesting. This loop could also probably be converted to a range-based for loop, but clang-tidy isn't smart enough to figure this out in this case. But I guess, of course, that makes sense. If the variable I is used outside of the loop, then we cannot use a range-based for loop because we need the value of the variable I is relevant. Okay, so yeah, that makes sense. Cool. So I wonder, actually, now that I think about it, let me keep this the way clang-tidy does it and then have a separate commit where we improve the naming. So yeah, it converted these from old style for loop to range-based for, which is nice. And again, the I name is not great. This one is pretty good for entry in entries. That's actually really nice. So here it didn't just use the I name, but it actually was smart enough to name it entry. Interesting. I don't know why it did that here and not in the other case. And then here, yeah, this also. Here also it used the proper variable name. Cool. All right. So let's run clang format again. And then we commit this. And then we improve the naming in the cases where it didn't do the right thing by itself. Okay. And so that would be primarily, let me have another look at the changes it did. Primarily these ones in DD Manager CPP and DXA Manager CPP. The other ones, it somehow was able to figure out the good variable name. So DD Manager and DXA Manager. So this should be called surface. And this one wasn't changed. And then DXA Manager. Oh, it also didn't change this one. Interesting, because it's iterating over two things at the same time. Right. Interesting. Okay, but it did change this one. LPDM6 sound effects. So what's going to be a good name for this? LPDM6 sound effects. Direct music segment. Maybe sound effects. Yep. Sound effect in list of sound effects. Cool. And here again, we are using the I variable after the loop, so we cannot convert to range-based for. Yeah, and I think that's pretty much it. Let's check, by the way, if we are still building and running. Yeah, seems good. Okay. Now, one thing to mention maybe, so this code doesn't have any unit tests, as you may have noticed, and so I'm just doing a very basic smoke test basically of does it run at all and does it work when I go in game. I think that's sufficient for this little small code base, and if we introduce bugs, then we can fix them later. Of course, if you're working on a bigger code base that's used in production, then you probably want to consider spending some more time up front getting some of the code under test, if that's possible, before you embark on a big refactoring journey like this, or you want to have some more thorough manual testing plans in place if it's not possible to get the code automatically tested. Now, games are in general tough to automatically test. Like, you can write unit tests for fundamental code, like basic utilities, containers, this kind of stuff. But it's pretty hard to unit test something like gameplay. I mean, you can also test logic, like, oh, how much damage does the player need to take before something happens and whatnot, of course. But like the game overall, like making an integration test for that is pretty hard. I mean, you need to have everything be deterministic, and you need a way to, instead of just rendering an image, have some other way to capture the state of the world. So I'm not saying that it's not possible, but it's pretty hard and would be a lot of work also in this case. And all the work that you need to do in order to get stuff under test, you're kind of doing blind, because you will have to make some fundamental changes to the code, and these are not covered by unit tests yet. So in this particular case, where we have such a small code base and it's easy enough to manually test it, I don't think it's worth the effort. But depending on what kind of application you're working on, it may be different. So yeah, this just as an aside. Cool. So now, let's see. It might be worth rerunning clang-tidy, because so many of these have now been fixed. It still complains, oh no, why does it not say no longer valid? Yeah, maybe let's rerun it. Clang-tidy. Oh, fixed partially. Oh, so this is the way of how you can run it on the whole code base. Well, that's good. Now we've found it. I didn't find it before. But, well, there you go. So instead of running it on the command line, as we did so far, we could also use this here to apply these fixes to the entire project. Okay. All right. So let's see. So here now we can actually easily run some of these on the whole project. So let's do that. Make member function const. Yes, please. So what did that do? Cool, yeah. That's very nice that it can automatically detect that these functions can be const and make them const. I like that. Would have been one of the things I would have also looked for, but if it can just do that automatically, that's even better. Just to be sure, I think if I do it from cline, it does automatically apply clang format, but let's make sure. Just in case, yeah, looks good. Okay. Apply clang-tidy. Make member functions const. Hold on, I made a typo there. Functions const. Cool. Then we have deprecated headers. Sure, why not? Let's fix that. And so then it uses the C++ versions of these headers, C headers, C library, standard library headers instead of the C versions, which is nice. So yeah, we can do that. And here we can see that it did rerun clang format because the header was moved based on the sorting. Apply clang-tidy, avoid deprecated headers. Cool. What else do we have? Delete null pointer. Right, yeah. So it's actually a delete on a null pointer is a no-op, so we don't need to check this manually. And same thing here. Okay, I like that. And then what else do we have? Explicit constructor. That's going to be making a constructor explicit that takes just one argument to avoid implicit conversions. So that's always good. The reason we don't find many more of these issues in this codebase, I think, is because this codebase is using init functions a lot instead of making proper use of constructors. So let's okay, redundant declaration. Okay, and so this one we already have somewhere else, I guess. I mean, yeah, I mentioned these last time that these are a bit weird, so I think I'm also going to do a general parse of the header files and straighten out these weird external declarations, which should actually be in a header of their own that's then included into all these header files. But it somehow figured out that this one is redundant and removed it, which is nice. So let's see. Do we still compile? Okay, cool. All right. And then let's see, what else do we have? Still have a lot of warnings, but probably not all of these can be fixed automatically. There's this one here, protype member init. Let's see what this one does. Okay, so that's the one I complained about earlier about not initializing shot data, and I think there's a better way to fix it, but fine, let's do it like this for now. Why would it do that? That doesn't really make sense, because this is a class that has a default constructor. No, these ones make sense because these are plain aggregate structs, so they don't have a default constructor. And same here. I mean, yeah, don't really like mixing this type of initialization and this type of declaring multiple in one. So maybe I will not do that. I don't know why it complains about this one. And also, I mean, so this one shuts up the warning, but really it's not quite correct because of this zero memory. Okay, so let me deal with this in a different way. I do think these are fine. Yeah, why not these ones too? But I want to deal with these manually. And this one I don't agree with. And this one also I want it differently. Okay, so let me revert this one and this one and deal with these manually. And we just apply clang-tidy partially. Initialize members. Okay, and so now we want to deal with this one. This is in sprites.h. And here we also have this sprite description, which is the shot data that's referenced in the other ones. So here, if we do null pointer, and I'm also going to convert them to not declare multiple values in one go. Right, so if we do this, then sprite description type has a default constructor, and we don't need this anymore, this zero memory, because now the sprite description, if we look at sprite.h, it has this member, shot data. And the complaint from clang-tidy was that this constructor does not initialize the shot data, which wasn't true. It was doing this, but clang-tidy probably doesn't know what zero memory is, and so it didn't recognize it. And so instead of doing this zero memory, we now have sprite description have these initializers, and so now it has a default constructor and will be correctly initialized just by declaring it here as a member, like so. So that's going to fix the underlying problem also. And then the other one was this asprite no list, which has these ones, but I prefer doing this equals something for like primitive types. And I also prefer declaring each member on its own line instead of doing this like multiple values in one. So let's do it like this and like this. And so this should also shut up these warnings, I believe. So this one is now grayed out. Does this mean not relevant anymore? Probably. We have here narrowing conversion, inclusion of deprecate C++ header. This is not relevant anymore. Inclusion of C++ header not relevant anymore. Randomness, conversions, redundant declaration not relevant anymore. We did all of these deprecated headers. Uninitialized record type. Aha, so it did that, I guess, because actually we have it open here. Because we don't actually have a default constructor. That's interesting. We have a destructor, but no constructor, because we have this init function. But so let's just add initializers here also, and then we fix that. Cool. So that should fix this warning. And these ones should also be fixed. So that was what clang-tidy did automatically. This one, clang-tidy fixed automatically. More narrowing conversion can be made const is fixed and can be made const. Yep. So most of the warnings that are remaining are about conversions and randomness. Interestingly. Cool. And this one's also interesting. May throw an exception that cannot be caught. Yeah. Well, that's a bit of a trickier problem to fix. For now, let's commit what we have. And so this, by the way, I didn't mention this before, but I did notice that there's a bug actually, which was... no, it's actually not fixed. Right. So you may notice that none of the enemies are shooting back at us, which they do if we run the original binary, the original one that I built way back. So here the enemies are shooting, right? And they don't do this in the version that we compiled with a modern compiler. And this was like this from the beginning of when I started working on this. I just didn't mention it. And I did look briefly into it, and I did figure out that it was because of an uninitialized variable, which might be actually, and I thought it might be one of these. Like, yeah, I thought it was this. The problem was that this current shot delay was not initialized. So I thought that maybe this would fix it, but maybe it didn't. Let's see. No, they're still not shooting at us. Okay, let me just rebuild, just to be 100% sure, because I feel like this was the fix for this issue. Yeah, okay. So again, stale build somehow. But yeah, so now the enemies are shooting. And the reason they were not shooting is because current shot delay was not initialized. And time also. This is one of the interesting differences between the old compiler and a modern compiler, that the old compiler seemingly did zero initialize certain memory, which the new one does not. And so it was always undefined behavior to not initialize these values, but with the old compiler it didn't cause any observable issues, whereas now it does. So we have this loop here where we increment this time variable, and whenever it's bigger than frame rate divided by 60, then we set it to 0 and we increase the shot delay. And then if the shot delay is bigger than this shot delay variable, then we fire a shot. And so now the thing is, if these are not initialized, they are some random value, which often happens to be interpreted as a negative number. And so we can increment them for quite a while. If this is like something like minus 32,000 something, then it takes a while until it reaches 0. And so by initializing these variables properly, we fix that problem. So if I remove these, which is the state that the code was in before we made this change, okay, so now they are not shooting, right? I add back in the initialization. Okay, and so now they are shooting again. Okay, yeah, so I thought this is a pretty interesting example of undefined behavior in the code, which is kind of dormant, and then you update your compiler and suddenly it causes a bug. Okay, so let's see. So then we have this change here also, which is also from clang-tidy. And so let's see what we have actually left now. All right, so we still have 51 warnings left. And here it only offers, oh, interesting, we didn't have this one earlier. Modernize use notice card. Well, sure. Why not? I guess maybe because these functions are now const, it's now adding this no discard attribute, because if the function is const, then the only reason why you would call the function is to get the return value. So if you then ignore, discard the return value, then that might be a mistake. And if the function is not const, then you might be calling it because of some side effect that it has, and so you may not need the return value. So yeah, that makes sense. Cool. Okay. So then it seems that the remaining problems it cannot fix automatically.